Alright, got cut off on that last example, so we were about ready to give the final answer by using the multiplication property of equality. So we're going to multiply here by the reciprocal of a negative 60, which is a negative 1/60th, and that looks like division by a negative 60 because it is. And finally, we get that a is equal to a 2 over a negative 60, which is unacceptable because these have a GCF of 2. So we're going to take that GCF out. And now we have a is equal to 1 over a negative 30. So in other words, a is equal to a negative 1/30th. And that'll be our final answer. Our next topic here is going to be to clear equations of decimals. Clearing equations of decimals is just like clearing equations of fractions because a decimal is a fraction. So what it boils down to in clearing an equation of fractions or of decimals is we're actually looking at the LCD as the largest number of decimal places. So I count the number of decimal places in each term, and then I have to multiply everything by a factor of 10 that contains that number of decimal places. So let's look at 0.5x plus 0.25 is equal to 1.2. So I see there's one decimal here, there's two decimal places here, and there's one here. So the largest number of decimal places is 2. So I'm going to multiply by the LCD that has a factor of 10 with 2 zeros. So that's 100. So I'm going to multiply this term by 100, this term by 100, and finally this term by 100. And remember that when we multiply a decimal by factors of 100, it moves the decimal. The number of places is the number of zeros to the right. So this is going to move the decimal 2 places to the right. So this will be 50x plus 2 places to the right. We have 25. And that's equal to 2 places to the right. We have 120. Now that there are no decimals, we'll proceed on with our addition property. We need to move this 25 to this side over here. So minus 25 added to both sides. So negative 25 added to both sides gives me 50x on the left equals 120 minus 25, which gives me 95. And from there, I need to remove the numeric coefficient, so I'm going to multiply by 1/50th, which looks like division because it is. And now I'm going to see that x is equal to, first of all, I want to simplify this. So I see that these are both divisible by 5 because one ends in a 0, one ends in a 5, so I'll take that out. So now I see that x is equal to, and 5 will go into here one time with 4 left over, and that'll go in 19 times, and 5 goes into 50 10 times. And so now I can do that simply. 10 goes into 19. That moves the decimal one place to the left, so this is 1.9. Now because my original equation started in decimals, my answer needs to end in decimals. My next example requires that I use the distributive property. Just like before, anytime the distributive property is there, we definitely need to make sure that we're using the distributive property. So I'm going to start out with the distributive property to distribute 0.25 over the x minus the 0.1, and that's equal to 0.5x plus 0.75. We'll continue this example in the next lecture as well. And I don't think I'm going to get it finished, so I'll just go ahead and stop right here.